Saturn's rings are beautiful. That's what we've always said. That's what every textbook shows you. A serene golden giant draped in halos of ice, drifting peacefully through the outer solar system. That image is a lie. Saturn is not beautiful. Saturn is a catastrophe, frozen, violent, and ancient beyond comprehension. And it has been quietly destroying everything around it for 4.5 billion years. Imagine you are standing on something solid. Underneath you, the upper cloud layer of Saturn. The wind is moving at 1,800 kilometers per hour. That's 5 times the speed of a Category 5 hurricane. You cannot breathe. You cannot stand. The pressure is compressing your body faster than you can process it. You last approximately 4 seconds. But that's not what makes Saturn terrifying. What makes Saturn terrifying is what lies beneath the clouds. What the planet is made of at its core. What it does to the moons orbiting around it. The moons that might have once harbored life. Here is the question. No one asks about Saturn. If it's just a gas giant, if there's no solid surface, no rocky ground, no dramatic crater, why does it feel like something hunting? Saturn is the second largest planet in our solar system. It has a diameter of 116,460 kilometers, roughly 9 times the width of Earth. If you hollowed it out, you could fit 764 Earths inside. But here is the first number that should disturb you. Saturn is 95 times more massive than Earth, and yet it is the only planet in the solar system less dense than water. Its average density is 0.687 grams per cubic centimeter. Water is 1. Place Saturn in an ocean large enough to hold it, and it floats. That sounds like a quirk. It is not a quirk. It means Saturn is, at its outermost layers, mostly nothing. A thick shell of hydrogen gas, then helium compressed slowly into something stranger and stranger the deeper you go. At around 30,000 kilometers beneath the cloud tops, the pressure crosses 3 million times Earth's atmospheric pressure. The hydrogen stops being a gas. It stops being a liquid. It becomes something with no name in everyday language. Metallic hydrogen. A state of matter so extreme, it conducts electricity like a metal while flowing like a fluid. This is where Saturn's magnetic field is born, 578 times stronger than Earth's. A magnetic bubble 1.1 million kilometers wide, large enough to swallow the sun itself and still have room. But that's not the terrifying part. The terrifying part is what happens at the core. Scientists believe Saturn has a dense, rocky center, somewhere between 9 and 22 times the mass of Earth. But they cannot confirm its exact size. They cannot confirm its exact composition. A planet 1.4 billion kilometers from us, visible to the naked eye on a clear night. And we still do not know what is at its heart. Saturn keeps its secrets. It has had 4.5 billion years to hide them. And then there are the storms. The hexagonal storm at Saturn's North Pole is one of the most disturbing structures in the known solar system. A geometric hurricane, 6 perfect sides, spinning at 320 kilometers per hour. Each side is approximately 13,800 kilometers long. The entire feature spans roughly 30,000 kilometers across. It has persisted for decades, possibly for centuries. No one knows why it's a hexagon. No other planet has one. It should not exist. And yet there it sits, turning slowly, perfectly symmetrical, as if placed there deliberately. What scientists found next changed everything. Let's talk about the rings. From Earth, they look like solid disks, clean, flat, permanent. They are none of those things. Saturn's rings are made of billions of individual particles, chunks of ice and rock, ranging from microscopic dust to objects the size of houses. They stretch outward for 282,000 kilometers from the planet's center. That is roughly 73% of the distance between Earth and the Moon. They are in places as thin as 10 meters. 10 meters, a distance you could sprint in under 2 seconds. That is the vertical thickness of a ring system wider than the Moon's orbit. But here is what most people never learn about the rings. They are disappearing. Saturn's gravity and magnetic field are pulling the ring material inward. The ice particles are being charged by solar ultraviolet radiation, caught in Saturn's magnetic field lines and rained down into the planet's atmosphere. Scientists call it ring rain, and they have measured the rate. Saturn is losing between 432 and 2,900 kilograms of ring material every second. Every second. At current rates, the rings will be completely gone in somewhere between 100 million and 300 million years. In the context of the universe, that is a breath, a blink. The rings you see in photographs, the rings that define Saturn in every human imagination, are already in the process of dying. We arrived just in time to see them. We are looking at something in its final moments, and we called it beautiful. That's not the worst part. The worst part is what Saturn does to its moons. Saturn has 146 confirmed moons. 146. The largest, Titan, is bigger than the planet Mercury. It has a dense atmosphere. The only moon in the solar system with one. It has lakes, rivers, and seas on its surface. Not water, liquid methane. At a surface temperature of minus 179 degrees Celsius, methane falls as rain, carves riverbeds and pools into oceans. And beneath Titan's surface, beneath the methane seas and the frozen nitrogen haze, scientists believe there is a liquid water ocean, sandwiched between layers of ice, kept warm, possibly by tidal forces from Saturn itself. This means Titan, one of the least discussed worlds in popular science, may have two separate environments potentially capable of supporting life. But Saturn is not done with Titan. Saturn's tidal forces are slowly accelerating Titan away from the planet at a rate of approximately 11 centimeters per year. As Titan spirals outward, the tidal heating that may be warming its internal ocean will decrease. Over millions of years, whatever warmth exists inside Titan will fade. Saturn gave its moon the conditions for life, and Saturn is taking them back. Now we come to Enceladus. Enceladus is small, just 504 kilometers in diameter. Against Saturn's 116,000 kilometers, it is a speck. But Enceladus is the most important place in the outer solar system. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, detected enormous plumes erupting from the moon's south pole. Jets of water vapor, ice particles, and organic molecules shooting 800 kilometers into space. Organic molecules, the chemistry of life, erupting from a frozen moon of Saturn. Cassini flew through those plumes. It tasted them. Scientists analyzed the samples and found molecular hydrogen, complex organic compounds, silica nanoparticles that form only when water contacts rock at temperatures above 90 degrees Celsius. There is a hydrothermal system inside Enceladus, a warm ocean beneath the ice, water and rock in contact, chemistry happening. On Earth, hydrothermal vents on the ocean floor host entire ecosystems, creatures that have never seen sunlight, surviving purely on chemical energy. We found the same basic conditions at Enceladus. And then Cassini ended. In September 2017, NASA deliberately steered Cassini into Saturn's atmosphere. It burned up in seconds. The decision was made to prevent any chance of contaminating Enceladus, to protect whatever might be living there from any Earth microbes that might have hitched a ride on the spacecraft. We sent a probe to Saturn's system. We may have found life, and our first response was to destroy the probe before it could get any closer. Think about that. We look at Saturn and we see rings. We see a portrait, a postcard. We do not see what it actually is, a 95 Earth mass engine of destruction and creation, simultaneously dissolving its own rings, stripping its moons of the conditions for warmth, and harboring, in its shadow, a small ice-covered world where the fundamental chemistry of life may be unfolding right now, in the dark, in the cold, 1.4 billion kilometers from the nearest human being. The Voyager 1 probe passed Saturn in November 1980. It has been traveling ever since, at 61,000 kilometers per hour, and it is now 23 billion kilometers from Earth. A spacecraft launched before most people alive today were born, still moving and still not even close to the nearest star. That is the scale we are talking about. We did not evolve to comprehend distances like this. We did not evolve to hold in our minds the idea that the rings of Saturn are falling into it, that the ocean of Enceladus may be alive, that our most important robotic explorer of that world was intentionally incinerated to protect a microbe we haven't even confirmed exists yet. But we should try, because the question of whether life exists in the liquid water beneath that frozen shell is not a science question. Not ultimately. It is the only question. If Enceladus harbors life, even microbial, even simple, then life is not a miracle. It is not a lucky accident that happened once on one pale blue dot. It is something the universe does, something it builds wherever the conditions allow, even in the darkness, even under 40 kilometers of ice, even in the long shadow of a planet that seems intent on consuming everything around it. Saturn is terrifying because it shows us how indifferent the universe is, and beautiful because it does it anyway. The Dragonfly mission is currently scheduled to reach Titan in the 2030s. It will land on a world of methane seas and nitrogen skies, 1.4 billion kilometers from home, and begin searching. What it finds, or doesn't find, may be the most important discovery in the history of our species, or it may find nothing. And somehow, that might be the most terrifying answer of all, because if a world like Titan, rich in chemistry, stable for billions of years, still remains silent, then maybe the universe isn't waiting to be discovered. Maybe it already is, watching. If this stayed with you, if you felt that silence, subscribe. Stay with this channel. Share this with someone who looks at the night sky and wonders what's really out there. Because the next story is even darker.